want someone to remind me what type of energy is kinetic energy. It's energy of what? Motion. What'd you say? Movement? Yeah. Same thing. Okay. The energy of motion. Okay. So if my velocity or my speed is 0, do I have any kinetic energy? I don't. No, I don't. Okay. I don't have any kinetic energy if my speed is 0. What about if I'm standing up on top of a cliff, or if I'm standing up on top of a building, or I'm standing up really high? What type of energy do I have? Potential. I have potential because I'm not moving, right? If I'm just standing there and I'm high off the ground, I've got potential. And then what if I stretch a rubber band really, really, really far? What type of energy does that have? Elastic potential, right? Or potential energy of a spring or something. However you want to say that, that's fine. Okay? We have the equations for all those. Okay? Let's go ahead and start just trying some practice math with these, okay? This says it's kinetic energy practice. So our kinetic energy equation is equal to 1/2 mv squared, okay? Now, algebra-wise, do we know how to deal with things that have a square like that? Do you know what v squared? It's like v times itself, right? So we're going to maybe use that a couple different times here, but I'm going to show you how I approach problems like this, like word problems. Do you guys like using word problems? Yeah, some people, a lot of people say no, but I'm going to show you what I think is the easiest way, okay? So we're going to, as we go through the problem, we're going to start making a list of all the information that we have, okay? So the first thing it says is how much kinetic energy does a 0.45 kilogram baseball have as it crosses the plate if it is traveling 15 meters per second? So that seems like a lot of information, right? But let's go ahead and start narrowing things down. The first thing I'm seeing is how much kinetic energy. That means that's probably what I'm solving for, right? So I like to make myself a list. I'm going to come down here and say KE is equal to a question mark, right? That's really what I'm searching for. That's the purpose of my problem. So I'm going to write it in as a question mark. The second thing it tells me is that it has a mass, or it says 0.45 kilograms. So what variable does that get assigned to? Mass. The mass, the M, right? Remember, this stands for mass. This stands for velocity. Okay, so that means my mass is 0.450 kilograms. Okay? And it says it's traveling 15 meters per second. So what do you think variable, what do you think that goes with? V, that is velocity, right? Velocity and speed are the same thing for us right now, so 15. Okay. You can leave the units on, but it doesn't change the way we solve any of our problems. Okay, so you can leave the meters per second on it there when you plug it in, but you don't necessarily have to. All right, so now let's just go look at our equation. We're solving for KE. It equals 1/2 times M times, sorry, I forgot the 0, times 15 squared. Right, and then we just plug it into our calculator and we solve it. Right, that's it. Pretty simple, right? We take the information out and we kind of make ourselves a list, and then we plug it into the equation. So I'm solving to find what's my kinetic energy. So let's get our calculators out and run that and see what we can find. What's the same as 1/2? What decimal is the same as 1/2? 0.5, right? 1/2 is the same as 0.5. So in my calculator, I'm going to put in 0.5 times 0.450 times, and then do you know where the square button is on your calculator? Okay, it's right over here. On this type of calculator, it's right over here. It says x squared. So I'm going to hit times 15, and then I hit that square button. Okay, and then enter. And so I got 50.625. Okay. Very good. Unit is joules, so we're going to attach a J for joules on the end there. Very good. Okay, questions with how we solve that? We feel okay about that algebra? Okay, let's look at the next one. How much does an object weigh if it is traveling 30 meters per second and has a kinetic energy of 4,300 joules? Okay, so we're going to just start picking apart the word problem. Okay, don't want word problems to be intimidating for you. I just want you to be able to pick out the information that you need. Okay, so this says, how much does an object weigh? So what do you think what variable might we be looking for? Mass. Good. So mass is going to be our question mark. Okay, mass is going to be our question mark. It says it's traveling 30 meters per second. So what variable do you think that goes with? V, right? V is 30. And then it says it has a kinetic energy of 4,300. So that's going to be my KE, 4,300. So now I just plug in those numbers for the variables. Okay? So here's my equation again. KE equals 1/2 mv squared. Right? But I said KE equals 4,300 equals 1/2 times m times 30 squared. Okay, do you have questions about how we put those numbers in? Does that make sense to everybody? Okay, all it is substituting. Okay, so instead of KE, I put in the number we have for that. 1/2 stays the same, we don't know m, and we know v is equal to 30. Okay, I want to make sure we feel comfortable plugging those numbers in like that. Okay, from there, I want to solve for m. So how can I go about solving for m? I need to get m by itself.
You could move all of the equations over and divide them. Or you could put 1/2 and 30 squared and then divide it to 4,300.
Yep. Okay, perfect. So we want to get m by itself, but realistically, all of these terms are multiplied by each other. It's 1/2 times m times 30 squared. Are we all on the same page with that? Okay, it's not added together or anything like that. They're multiplied. So what I'm going to do is I'm going to go ahead and multiply the numbers that I have. I'm going to multiply those together, and I'll keep m attached to it. So let's go ahead and take 30 squared times 1/2, or 0.5, and see what we get when we do that. Did you get a number with that? What is it? 30 squared. I don't know if you put it in the squared for 30. That's right. I got 450. Is that better?
No, because my calculator is working from.
Right? It's not just 450. What has to be attached to that? It's m. 450 times m equals 4,300. Okay? Which means now I'm going to do what to get m by itself? I'm going to divide this whole side by 450, and whatever I do on the right-hand side, I have to do on the left. So I'm going to cancel that there, and I'm going to take 4,300 divided by 450, and I get m equals, I got about it goes 55555, but I'm just going to round it, 9.56, and our units would be kilograms. Is that what you had? How do we feel about the algebra with it? Is that easy algebra for us? Okay, good. I'm just not sure where everyone's at, so I want to make sure we feel okay about that.
So if it's repeated.
Okay, this asks us how fast is a 3,000 kilogram car moving if it has 53,000 joules of energy. Okay, so it asks us how fast. So what does that mean, the variable that I'm solving for? Velocity, right? So v is going to be my question mark. This 3,000 kilogram is going to be my mass. And then it says I have 53,000 joules worth of energy. Okay, it's in motion, so we know that's kinetic energy. 53,000 joules. Okay, so now when we go to set up our equation, KE equals 1/2 mv squared. I'm going to substitute here my numbers into that. 53,000 equals 1/2 times the mass, but I have v squared. That's what I'm looking for. Okay, so how can I go about getting v by itself? Right? Okay, we're going to multiply. I'm going to multiply these two together first. 0.5 times 3,000. That gives me 1,500 times v squared equals 53,000. And then I need to do what? I needed to divide it over. So divide by 1,500 That cancels, divide by 1,500. So that gives me 53,000 divided by 1,500, which is 35.33. Now, is that my velocity? No, because that's equal to v squared. So do you know how we can get it to just v by itself?
Square it.
Okay, we don't square it. Do you know how to cancel a square? Okay, so the way we cancel a square is to take the square root of it. To take the square root. Okay, because let's look at this. If I had 2 squared, that equals 4, right? But if I take the square root of 4, that gets me back to 2. You see how that works? Square and square root are almost like reciprocals of one another, right? That's how you reverse one or the other. Okay, so I need to get v by itself. I'm going to take the square root. So now that means on this right-hand side, I'm just left with v. And then on the left-hand side, I'm actually going to take the square root of that. Do you know how to do that in your calculator? Right? In my calculator, I have to hit second, and then I hit the exponent button because that's where square root is. So I hit second square root, and then I can hit second answer to put that 35 right in for me. And then I hit enter. And I get about 5.94. Okay, so V equals 5.94. And that unit would be what? Good. Meters per second. Yep. Okay, so I need to know what questions you have about the algebra part of that. Does that make sense to get rid of the square? We're just taking the square root then of both sides. And by taking the square root of this side, all we do is get it down to regular v. Okay, it doesn't change the math, but when we do it on this side, we're actually finding what is the square root of 35. Okay, and do you know what square root is in general? Mm-hmm. Right? It tells us what number times itself equals 35.33. So now if you were going to go plug this back in, 5.94 squared, right, you get 35.33. Right, or very close to that, depending on where it's been rounded. Okay, so that's showing you how we're getting to that point. Okay, do you remember the equation for potential energy, or why don't you look back real quick at an equation for potential energy? Yep, PEG equals mgh. And what's the other type of potential energy we have? PE of a spring, which is 1/2 kx squared. So without even reading the problem, we know we've got 2 possible equations we could be using for potential energy. So we've got to identify which one we need first. Okay, so let's look through the problem. It says, a boy is holding a ball on a 30-meter cliff. If the ball has a mass of 7.5 kilograms, how much potential energy is stored in the ball? So that means, does it have anything to do with springs? No, so that means we're looking at the potential energy of gravity. So we're going to use that equation. Okay? It tells us that we have a 30-meter cliff. So what do you think, what variable does that represent?
Height.
Height, good. So my h is going to be 30 meters. It says the ball has a mass of 7.5 kilograms, which has to be m. And what do we always know about g right there? Do you remember what that is?
Gravity.
It's gravity, and it always has a set value, a set number. Do you remember what it is?
9.
It's not just 9, it's 9.8. Okay, so you can write that in your list if it helps you, but you don't have to since it's one that we just always know. Okay, G is 9.8. And so I'm trying to find how much energy is stored in that ball, which means I'm really solving for PE. That's my question mark. Okay, so now I can set it up into the equation. Potential energy is equal to mass, 7.5, times G, which is 9.8, times our height. Okay, you see, I don't have to put the units in here because I know what my final units are supposed to be, right? So I don't bother putting in the units with the problem. There will be some instances where I think it's really important to keep the units in the problem, but for right now, this isn't one of those things, okay? So let's see, I take 7.5 times 9.8 times 30, and I get a potential energy value of 2,205. Agreed? And what's our units with that? Joules. Okay. Yes.